Let's start. First things first. Probably because there's so few of you, I won't get the same depth or level of questions at the Q&A portion. So I am going to say if you want to see a good tutorial, I emailed out 2 from the past. Or if you go to my YouTube channel and you type in Physics 12 Momentum Tutorial, you'll find, I think, 5 of them from the past few years. Pick the ones that have the most viewership. Those are probably the better ones. I don't know. So, what are you going to see? I want to talk about the written section first. On the written section, you're definitely going to see a collision at an angle. Something like this here. I'm just going to change the numbers. Or I'll ask, are you guys okay with these kinds of questions where we collide and you have to use the cosine law and you have to use, let me just pause for a second here. Where's my video? Are you guys okay with questions like this? Clay's nodding. Yeah. Okay. Yo, yeah. So there is going to be, Kiowa, a question where there's a collision at an angle, and it's going to be, it's not going to be a right angle. So something like this. You okay with those?
These ones, could we go over it actually?
Yes, that's what I'm asking. Okay. So I'm going to make up different numbers because this is from your review. So I'm going to go copy. And again, you can write this down if you want, or if you're here till the end, I'll print it up for you. And I will also post it online, so even if you're not here until the end, it'll be under block H or block A, whichever block you're in. And hopefully you know how to find my website and all that stuff. 3.4 meters per second. 0.6 kilograms, and now it's a whole new question. Okay. Is there a collision? This is a job for conservation of momentum. Now, just because there's a collision doesn't always mean there's conservation of momentum. Really what I should say is it a collision, and are they asking me to find a velocity or a mass? I'm probably going to use the thing that's got an M and a V in it, conservation of momentum. Okay? I would then start out by going like this. The sum of all the initial momentum equals the sum of all the final momentum. I will probably give you 1 mark or a half mark for that, for cluing in that that's how we solve it. You okay with that, Kiowa? And then we always pause, we try and analyze this. First of all, do you think we're going to be doing angles in this question or not? Yeah, so I'm going to be thinking vector diagram and tip to tail and all that. Okay. I say before the collision, what's moving? Mass 1, mass 2, both, or neither? That means momentum 1 initial exists. Momentum 2 was 0. So who cares? Is that all right? Wham, they collide. I'd normally do it louder, but I got kids writing tests in here and I don't want to scare them. After the collision, what's moving? Mass 1, mass 2, both, or neither? Separate or stuck together? If they were stuck together, this would be way easier. By the way, if they were stuck together, this would have had to have been a linear question, because if you have only momentum to the east coming in, you must only have momentum to the east. Well, no, I take that back. If they're stuck together. Now, if they're separate, well, I bet you one went north and one went south, and those will cancel each other out a little bit. But the way I write that, Kiowa, is I go momentum 1 final and momentum 2 final. Kiowa, you told me angles, yes? So I'm going to dulp. Looking at my picture, what's the initial direction of mass 1? So as a picture, I'm going to draw this. How long will that arrow be? Mass times velocity. 0.6 times, I think I said it was 3.4? Yeah. So let's fill that in. 2.04. When they collide. After the collision, which one of those is momentum 1 final on the right-hand side? The top mass or the bottom mass? Top one. Did they tell me it? Yep. So I can fill that in. I'll say it went Do-do-do. 30-degree angle. The mass is 0.6. The speed is velocity is 1.8. .08. Plus, do I know the momentum of object 2, Kiowa? No. But I know what it looks like. Yeah? So I'm going to say, well, something like that. You see where I'm adding two vectors together? On the right-hand side, see the plus sign? How could I add those two vectors together? Okay, so I'm going to do a triangle, and again, I try and draw a fairly big one. Yours are a little small, and that leads to difficulty, I'm telling you. So I'm going to go like this. Here's the ones I'm adding tip to tail. I'll draw the easiest one first. That's the one that I know. So it's going to start out by going 30 degrees up, 1.08. And here's the nice thing, Dustin. I know what these two add to as a direction. Apparently this plus this gives me due east. So if I'm drawing these, I know to go and I'm going to stop pretty much there. I'm not going to go further, I'm not going to go shorter, because I know that apparently those two add to 2.04. This is momentum to final. That's a terrible vector symbol. Yeah? SOHCAHTOA? Is there a right angle? No. There might be. How will you know if there is a right angle? If when you read the question, you don't see any degrees. All you see is due south, due east, due north, due west. But as soon as you see a 37 degrees something of something, it's going to be sine law, cosine law. Or in this picture. Okay. So what do I want to find, Kiowa? What do I want to find? That thing, right? Momentum of object 2 final. So I'm going to write this equals what squared plus what squared minus 2 times what cos what? 1.08 squared plus 2.04 squared minus 2 times 1.08 times 2.04 cos 30. Again, Dustin, you don't have to memorize that. It's on your formula sheet. Although probably in this unit, most of you have just spotted the pattern of how it all fits together, and you've memorized the pattern, which is a much better way to wrap your brain around the cosine law, by the way. I never memorized it in terms of A, B, and C. I always know it's, oh, what squared equals what squared plus what squared minus 2, what cos what. Did I hand up? I do it afterwards. You might be able to, if you have a good calculator. You could. I may teach it that way someday. I know it just means you're going to have to use brackets, right? Yeah. So it's going to be 1.08 squared, right there, plus 2.04 squared minus 2 times 1.08 times 2.04 cos 30 square root. Why do I have to square root? Because the cosine law doesn't find you this, it finds you this squared. Did you get 1.229611996? I'll go 1.22961. momentum to final equals whatever the heck I said, 1.22961. 1.22961. That's the momentum. It's not what they want me to find. What do they want me to find? How do I find a velocity if I know the momentum? By the mass. Is that okay, Kaiwa? Yeah. So, if I want to find, because you were the one that asked me to do this question, my friend, the velocity of object 2 final, it's going to be this number divided by the mass of object 2, which was 0.3. If I do that, 4.098, you know what, 4.10, because the 9 is going to get bumped up and become a 0 and a 1 there. Meters per second. If this was a multiple choice question and I just said find the speed, you're good. Okay. If this was a multiple choice question and I just said find the direction, you could actually stop right here and use the sine law, because the direction of the momentum will be the direction of the velocity anyways. Is that okay? But I didn't ask for those, I asked for the whole shebang. Well, that's a speed. To make it a velocity, I need an at. Let's go look at my picture. Why don't write this down, why don't I want that one there? Every angle has two sides.
No, I said like forgot. I had it, but it slipped.
It's not a slanty next to a slanty. I can use it, except I don't want it, because the vector that I'm always trying to find is where the resultant comes from. It comes from here. Oh, and this angle won't help me because that's a slanty of a slanty. We have a suggestion? Other one. Ah, what I can do is I can say there is a Z there. See it? And because there's a Z there, this angle and this angle are the same size. They're not the same north of south, east of west, what of what, but they are the same size. So, I'm going to find that theta, but I'm going to find that theta because not because it's useful, it's because it's the same size as something that's useful. How would I find this here theta here? Sine of theta over what? 1.08 equals the sine of 30 over what? Ah, my momentum, which I found to be 1.22961. Now, Kiowa, I cross multiply. What? Oh, that's the sine of theta. How do I find theta? .1 degrees. I'll go 26 degrees. What of what? North of south, east of west, what of what?
South of east.
Ah, because this is the one that I want. Right?
That's the only thing I don't understand. Saying south to east. Yeah, that's the only thing I have trouble with.
Are you okay that it's this angle physically sitting there, that is the one that I want?
Oh, okay. So, okay, yeah.
Because this is where my vector is starting from.
Yeah.
Are you okay with that part, Vikas, or not? So, to give it the what of what, I'm never going to, the of blank is never the slanty, the diagonal. It's always the one that's either dead horizontal or dead vertical. So what's this one here? East. What of east to get down to south of east? South of east. Start out going east and go south of east. Is that okay? Yeah. And probably one or two more on the multiple choice, but I think on the multiple choice, rather than ask you for the velocity, magnitude, and direction, I might ask you for the speed, which means you could get to the divide by mass stage and quit, Dustin. Or I might ask you for the direction, which really means once you have the momentum, you don't actually need the velocity. You can find the sine law direction from that. I think that's what I did on the test. Okay?
Could we see an example of that, how it's worded? Or is it?
Sure.
So Mr. George has told us the actual test.
Yeah, problem is I'm videoing, so even if I'm quick, you just pause it and still read it. Right here, number 1.
Okay.
Okay? A 2 kilogram puck traveling due what? Collides with a 1 kilogram puck traveling due? Definitely angles. They stick together on impact. Oh, so what's moving after the collision? Both. What's the resultant? Oh, all they care about is the direction. This one's kind of nice because it's right angles. You could probably set it up and it would be very quick Pythagoras and SOHCAHTOA trig, not sine law, cosine law, thank God. Okay? And you can see all they want is the direction, not the velocity. I think there's one in here just wants the speed as well. Here, speed and direction. Nope. Find the mass. Probably not.
Is that a question about?
I had an answer.
How you said that if the world stopped rotating, we'd all fly in certain depth because of the amount of velocity we have. What if, like, let's say this was an empty room and a person was just up against a wall already? What would happen to them?
The problem is inside you're mostly organs floating in liquid, and your organs would go splooshing against your back very, very hard, and you'd still die. Because it's not the impact that kills you, it's the acceleration that kills you. In fact, I have a shirt that says it's not the fall that kills you, it's the VF minus VI over T, which is kind of a joke, but actually we're just looking at it right now in Physics 11. It's why if a big truck and a little car, let's say a moving van, or Lost in Cooper, have a head-on collision. Sorry, people listening at home, but we're asking a good question. If they collide into each other head-on, forces come in pairs. They both experience the same force. Why does the little Austin Cooper, Mini Cooper, have so much more damage? Why is the occupant so much worse off? Force is what times what? Mass times acceleration. Big mass for the truck, tiny acceleration. Small mass for the car, you have to have a big mass. That's our big acceleration. In fact, let's take it to its extreme. Let's imagine a bug hitting the windshield of a bus. They both experience the same force. Why? Newton's third law. Forces come in. Okay? Bus has a huge mass. I bet you its acceleration is like 0.0000. You know what? It's negligible. It's so small that I'll bet you the gaps between the molecules can absorb it and no one notices. What's the bug's mass? Very small. So what's its acceleration? I can sum it up in one word. Splat. It's going to disintegrate, basically. Okay? So same idea if you then went smashing into the... It's the acceleration that does the damage. So if the Earth suddenly stopped moving and we all went smashing into the eastern wall, even at this latitude, we're not surviving. Okay? It's an interesting thought experiment, though, to also, well, what if we somehow got into like these crash coincidence and things? Would the, because the other thing that would happen, the atmosphere is all moving that fast as well, which means I think you'd have instant hurricane force winds of 1,600 kilometers per hour. Because the air molecules have mass, they're going to keep moving, right? Oh, yeah, yeah. Oh, it's a lovely little thought experiment. We'll pause for 1 second. What else will be on the written? There will be an explosion. What do I mean by an explosion? The initial momentum of your object is 0. So you know what the final momentum of your object is? So there's a couple, it doesn't have to be like a wham, they explode really, really fast. Here is an example of what I consider an explosion. I saw it right here, Mr. Dewick. Sure. A stationary life raft of mass blah, blah, blah is carrying 2 survivors with masses of 55 kilograms and 72 kilograms, respectively. They dive off the raft at the same instant. What speed does the raft start to move? Having said that, let me give you one even more similar to what's on your test. An object of mass 224 kilograms explodes into 3 pieces. Piece A, 88 kilograms, flies off due north at 36 meters per second. Piece B, 100 kilograms, flies off due east at 71 meters per second. I'm just making up numbers here. Find the velocity of the third piece, and we'll call it piece C. The reason this one is a little nicer than the one on the quiz, because I heard you say the one on the quiz, here, do you notice there's no degrees, which means it's going to be in a right triangle. It's when you see the 28 degrees north of south, it's going to be a cosine law, sorry.
So will the explosion have?
I gave you one with cosine law, sine law on the quiz. The one on your test will be a right angle one.
Okay.
Hey, better yet? No, we'll do this first. Okay. Is there a collision? No. Is there an explosion? Oh, is there a jeune? This is a job for conservation of momentum. So I would start out, Kiowa, by saying the sum of all the momentum before the explosion equals the sum of all the momentum after the explosion. Before the explosion, what's moving? Piece A, piece B, piece C, all or neither? Oh, what's my initial momentum then? What's my final momentum then? It's going to be 0, but I'm going to break it up vectorially. Because after the explosion, what's moving? Boom! They explode. After the explosion, what's moving? All of them. So I'm going to have momentum A, momentum B, momentum C. By the way, you notice how I am drawing the vector symbol because I want to remind myself I can't just go 88 times 36 plus 100 times 71 equals PC. I can't just add them up. I got to do some trig. In fact, let's dulp because there is going to be angles in here. What's the scroll up, Mr. Dewick? There we go. Piece A, what direction does it fly off at? So if I'm going to draw that, yoink. And if I want to put a size on it, it's going to be mass times velocity. Someone on their calculator go 88 times 36?
Can't do that one in your head? Come on.
Okay. Sorry, what? Plus? What direction is piece B? I can do that one in my head because it's 100 times 71. I think that's going to be 7,100. Plus, you walked right into that one. What direction is PC? It's a trick question. So if I don't know, I want to remind myself, because I'm worried if I don't put something there, I'll forget to draw the vector. So that there is that's reminding me, hey, I better draw that. That little effort it takes to put the question mark there is good bang on the buck. Yeah.
It would be like that, right?
I don't know. Let's find out. I have two vectors. How would I add those two vectors together?
Yeah.
So I have no problem if you go that way, then this way, or if you go this way, then that way. Both are acceptable. You'll get a different angle. So let's suppose the actual angle is 40 degrees south of east. You might get 50 degrees east of south. I'll take both. I'll take both. Meanwhile, since I'll go A, B, and C, I'll go up first. 3168. 7100 is more than twice as big as 3168. So Kiowa, just so I'm roughly to scale, I'll probably do that. 7100. Now, if I wanted the resultant, which really would mean if this was a collision, I would go like that. But that's not what I'm doing here. Here, I know what all three add to. What do all three add to? 0. What does 0 look like in a vector triangle? Comes back to where I started. Most common mistake I see on this question is kids go up and right because they're so used to just adding tip to tail. The reason, Kiowa, we're coming back here is that is what 0 means in a vector triangle. You end up back where you started from. Is that okay? Yeah. And, yay, there's a lovely right angle here, which means I can pull up Pythagoras and SOHCAHTOA. Yes?
Say you get this question, say you get it wrong.
Yeah.
That's something you look for a half line.
What?
The
The most common mistake is kids get the theta wrong because they drew it this way, and I think I cap it at 5 out of 7 because to me that's a pretty serious error. But if they do everything else, I think it's 5 out of 7. I have to go look at my answer key. I don't know. I didn't open that up. So it's going to be this. Oh, and here is momentum of PC. So PC squared equals 7100 squared plus 3168 squared. And I actually showed you this is the cosine law in disguise because you could actually go minus 2 times 7100 times 3168 cosine of 90. It's just that the cosine of 90 is 0, and so all that stuff cancels. Hashtag nerd trivia. Come on. Square root. 777, 4.7. The momentum of PC is 777, 4.7. This is momentum. So going back to your question, Mac, common mistake number, whatever we're on, kids think that's the answer. That's not what the question wanted you to find. I've got to divide by the mass to find the velocity. The velocity of object C is going to be 7774.7 divided by, now what's the mass? Let's see, I told you the total mass was 224, and I have 88 and I have 100. I guess I'm going to have to subtract 224 minus 100, that's 124, minus 88, it is 36. I don't like that just because I'm worried kids might get this 36 confused with that one. Usually I try and make up numbers so that there's less chance of being confused, but that's okay. It is what it is. $21.5. Now, before I go further, instead of asking Kiowa what the velocity was, I could have said find the final kinetic energy of piece C. In which case now, I could just go a half times 36 times 21.5 squared. I could quit because since energy is a scalar, I don't need the direction. Right? You okay with that? Or I could have asked, what's the total energy of the bomb? And you'd go a half mv squared to the first piece, plus a half mv squared to the second piece, plus a half mv squared to PC. And you have to find PC. And you could say, oh, this bomb had a total energy of this many joules. I didn't this time, but that actually might be a cool question because that's almost more interesting than how fast. How big is the bomb? Note to self, I may change that next year. That's a nice question. Yeah.
When I did it on my calculator,
Oh, you know why? Because I missed a decimal point here. I'm totally wrong. 777.4.7. Thank you. 215.96, so 216. Thanks, Mac. I never make mistakes. Then to find theta, theta is always where the vector originated from, not where it points to, where it came from. By the way, that theta there, north of south, east of west, what of what? South of west. By the way, southwest means an exact 45-degree angle, technically. So if you just said southwest, I'm marking that wrong. South of west and an angle. So I'm going to leave a little bit of a space here. South of west. Holy smokes, I think I can use opposite, adjacent. Trig is tough to do in your head because it doesn't. There's no nice pattern to extrapolate. I know the sine of 30 is 0.5 and the cosine of 30 is 0.866, so I can get close to stuff like that, but trig in your head is very difficult. I won't say impossible, but I haven't heard, even when I read about old-time science guys that were good at math in their head, like Feynman was quite famous for doing arithmetic in his head. I haven't heard him doing trig tables in his head. 24 degrees. Is that okay? Did you have to go, or you got a few more minutes still? Because you look like you're packing up.
I'm supposed to pick up around 4, so I'm just pretending.
Okay. I want to really talk about two more things. Okay? Third written question. Something like this. Okay? What's happening right here? Collision. Conservation momentum. And I'm pretty sure after they collide, it's no longer going to be going 8.5 meters per second. It's going to slow down. What's happening right here? Conservation of energy. Okay? There is going to be one of those on there. So here's the hint you got. So there is going to be a change in height, change in speed, yucky, curvy path. So also something like, I'll just cut and paste one in here, Mr. Dewick. This here. I'm not going to walk through it. I'll paste it in here. You guys can try it. I have a handwritten answer key showing all my steps. Okay. This one is worth 5 marks because I think there's a using principles of physics right to explain part 2 or something like that. But on the multiple choice, there's going to be several questions along these lines. Let me find. I know what I'm looking for.
They hit the wall and stuff?
Yeah, but I want to get the whole schmear. Here, this works. Something like number 28. Because this is bringing both impulse, velocity, and I see force, if I had asked that too. So a tennis ball traveling east is struck by a tennis racket, giving it a velocity west. What are the magnitude and direction? First of all, what's another word for impulse? What's another word? So when I say change momentum, what do I really mean? Impulse. When I say impulse, what do I really mean? You okay with that? Yeah. So here, I can find impulse two ways. I can either go final minus initial, because momentum is mass times velocity, or on your formula sheet, it's also force times change in time. If I know that there's a force and I know how long the force acted for, that's really what causes a change in momentum. I think I did my nerd trivia. This is why Star Trek called them the impulse engines. The impulse engines apply a force over a time. They change the velocity of the Enterprise. Okay. Which one would I use here? Well, I think I'm going to use the MV final minus MV initial. However, a nice extension to this question would be if I said, if the impact lasted 0.1 seconds, what was the force? And then you'd have to divide everything by t to get the F by itself. Meanwhile, the key with this question is going to be mass. What's the final velocity? Minus the mass. What's the initial velocity?
Negative 15.
What?
Negative 15.
Since you guys decided to let West be positive, because you told me V final was 25, negative 15. And that's important because if I get a positive answer here, a positive answer will mean West. A negative answer will mean East, because you can see there's a directional component here. Can someone quickly crunch that? Oh, you know what? I get a minus minus, which is a plus. Yes? You know what? I don't want to do that so that when you print this, you'll know what the heck we did. Could you crunch that for me then, Mac? I think it's going to be C and D, the bigger answers, because the minus minus making a plus would make it bigger. Positive or negative? What does the positive mean based on what you guys decided? 3.2.
No, I got 30.
I think you typed it in wrong. Oh, you know why? I typed the mass wrong. It's 0.08. I'm telling you, I'm in a slump.
I think we should all get extra bonus marks for ourselves.
I worked a 14-hour day yesterday. This is what you get. Getting old. Okay? So you can expect something to do with a change in direction. How can we change a direction? Bouncing off of a wall? Oh, bouncing off the ground, like even dribbling a basketball is a good change in direction. You can expect something like that. And what you really want to realize is whenever I'm talking about impulse, what am I really talking about? Okay? And there's two ways to find change in momentum. The usual change in anything, which is always, what's change in anything? Final minus initial. But don't forget, I can also find the change in momentum by force times time. Right? That's on your formula sheet. Okay? So I wanted to mention that. Who's block A here? You? Okay, I did this with my block G's or H's because they're writing the test before you guys anyways, but are you ready? These are the questions that I like. Yeah, there'll be some overlap. I can't remember which ones I said. You can expect something like number 2 in that I might give you a collision in a straight line, but for giggles ask you something about energy, because a straight line is so much easier than an angle. I wouldn't want to give you full mark. This would be a good multiple choice question. So I like number 2, I like number 2, I like number 2.
Something like this straight line. See ya.
I like number 6, I like number 6, I like number 6. I like number 9. I like number 11, I like number 11, I like number 11. Love number 14, love number 14, love number 14. Okay. What I don't like about number 16 is they're asking you to find the mass. I'm not going to give you a cosine law, sine law, find the mass question, but I like the diagram of, hey, you can expect to see two objects at angles sticking together. That too is totally fair game, especially because they move off in a nice straight line. Okay? I think there's going to be one for that later on. 17, I like 17. Oh, 18. You know what? There it is. I like number 18. I'm saying no. I like number 18. Here's an example of bounces back, rebounds, and here's the time, and it wants the average force. That's putting both definitions of impulse together. So I love number 18. I love number 18. I love number 18. I like number 19. I like number 19. I like number 19. I like number 21. I like number 21. I like number 21. I sort of like 22 in that it's an explosion. The only reason 22 is more difficult is your initial momentum is not 0. Your initial momentum is 7 times 12. So here it's actually going to be this plus this equals that. It is actually a collision at angles. I'm not wild about it, but I'll say meh. When you look at my answer key showing all my steps, you'll go, oh, I see what he's getting at. trust me. 23, I like 23, I like 23. I like 24, I like 24, I like 24. I like 26, I like 26, I like 26. 28. I like number 30, I like number 30, I like number 30. I like number 31, I like number 31, I like number 31. 33, I like 33. Now 33, if you look at it, Mac, look up. Just look up. It says you want the objects to remain, what word is that there? So what's their final momentum if they're all stationary? So what must their initial momentum have been? 0. This is a reverse explosion. Normally an explosion, everything starts stationary and then boom, they explode. This is the opposite of that. Everything starts, boom, they explode and ends up stationary. But I still think in number 33, you'll end up with a vector triangle that ends up back where it started from to show a final momentum of 0. Okay. So this is, to me, a nice explosion-y kind of question. Okay. Just a little weirdly worded. It's a reverse explosion. I like 34, I like 34, I like 34. .37 is overly tough, but I like the concept. What's number 37 asking me to find? How would I find the change in momentum? What's change in anything? Final minus initial. I think here it wants you to subtract vectors, because I see angles. Okay? I would have no problem asking you to subtract vectors if they were north, east, south, west, right angle triangle vectors, not subtracting cosine law, sine law vectors. But I would have, because change, again, what's change in anything? Final minus, how do I subtract vectors? I don't, I add the opposite. That might be a nice multiple choicey kind of a question. Find the impulse. Oh, wait a minute. The final velocity is north, the initial velocity is east. Oh, subtract the vectors, please. But I'm not going to give you the final velocity is 30 degrees east of south. Cosine law, subtract the vectors, please. No. Oh, I like number 39. I like number 39. I like number 39. And then I told the students, oh, there's still more. Hang on. In terms of scholarship questions, the life raft question, which is, yeah, here, 47, shouldn't be scholarship. As far as I'm concerned, this is an explosion. It's slow. Well, it's, what's the second word of the question? Look up. What's the second word of the question? Oh, so what's the initial momentum? So what's the final momentum? You got 3 objects. You got 2 people, one diving north, one diving east. I guess the raft is going to move that way, and when you add them, it's going to be a vector triangle with right angles, so SOHCAHTOA and Pythagoras, that comes back to where it started from. I don't know why that was a 10-mark scholarship question in the past. It's not that hard. So that, to me, is fair game.
What does it mean by 10-mark scholarship question?
On the old provincials, there used to be 2 provincial exams. In the 80s and 90s, you would write a 2-hour provincial exam. It was worth 50% of your grade, by the way, half your grade. And then after everyone else left, the nerds would, I think you had a half-hour break, then you came back and you wrote a 1-hour nasty scholarship exam. And if you scored over 1,500 as a score, I don't know how it was marked, but if you got over 1,500 on 3 exams, you were guaranteed, I think $1,000 of scholarship money. Wow. Oh, here's the funny part. You ready? Do you know what I got back in the day in 1987 when I graduated? $1,000. Do you know what you guys get in 2016? $1,000. Talking, going full circle to your inflation. Are you kidding me? $1,000 got me actually a full year of tuition at UFV at Fraser Valley College. $1,000 now gets you a couple of books. So that's one I've been lobbying to change. But now the positive, there are far more other scholarships for you guys than there were when I was in high school, but still.
We should find out.
So there's your hints. Is that okay?
Yeah.
So I'm going to go